Good evening. Students, are you able to hear me clearly?
Yes, sir.
Okay. The board is also visible clearly.
Yes, sir, it's visible.
Okay. What was the last topic where we ended that day? What was the last
Property 4, sir, with a question.
question?
Yes,
Did
sir.
we do property number 5 and 6 that day?
What, sir?
Did we do property number 5 and 6?
No, sir.
Okay. Do you remember the question? What was the question?
Yes, sir.
Don't
Sine
remember.
inverse x plus sine inverse y plus sine inverse z equals 3 pi by 2.
Sine inverse of.
X plus
Okay.
sine inverse y
Huh.
plus sine inverse z
Okay.
equals 3 pi by 2.
Okay.
Then the possible values satisfying the equation x power 100 plus y power 100 plus z power 100 plus a square by z power 50 plus y power 50 plus z power
I
50
think so.
equals.
We done numerical. I think so.
Yes, sir, we completed this.
We completed this, no?
Yes, sir.
Okay. Okay, so we'll move ahead. I had shared the PowerPoint presentation also. And again, today I have shared PDF. Will not waste much of the time, but I'll just share this screen and explain you some properties and then we can start with the numericals directly. Is that fine? Is it fine?
Yes, sir.
Okay. You're able to see the screen, right? So these are some formulas. Okay. Just a minute. Okay, these are some formulas which we require. The entire inverse trigonometry is formula based, and if we don't remember the formulas, we'll not be able to solve. So this is the property number 6. See, tan inverse of x plus tan inverse of y, we have written three different formulas, and this we should remember. It's important. See, in one case we have written for xy is less than 1. So suppose if you have something like this, tan inverse of 1 by 21 plus tan inverse of 1 by 8. Okay, so in that case, this is your value of x, this is your value of y. So when you do x into y, so but obviously you are going to get xy less than 1. Okay, so in that case, you can apply the first formula which we have written as tan inverse of x plus y upon 1 minus xy. Now you don't have to by heart or worry about this because we have written similar formula for trigonometry. Right? If you just remember tan of A plus B, we used to write it as tan of A plus tan of B upon 1 minus tan of A into tan of B. We used to write something like this. Okay, so it's like that only. And due to the shortage of time, I think so. You have other teachers also. So we derive this formula from here only. Okay, and that is why there will be always similarity. Instead of x, you have tan A over here. Instead of y, you have tan B over here. So exactly, it is the same formula. Okay, which was for tan of A plus B. So you can relate it and you can remember it. So suppose you have something like this, that is the time when you apply this formula. But suppose you have something like this. Say you have something like this, tan of 2 plus say tan of 5. So this is your x and this is your y. So when you do x into y, okay, you get 10, which is but obviously greater than y. So in that case, you have two formulas. Okay, if your xy is greater than 1, then you have two formulas, tan inverse of x plus tan inverse of y. Okay, can be written as 5 plus tan inverse of x plus y upon 1 minus x square. This is when your x is greater than 0, y is greater than 0, and xy is greater than 1, which is this case. My x is 2, my y is 5. So both are greater than 0 and my x into y is greater than 1. Okay? And this will become minus if my x is less than 0 and y is less than 0. But again, the condition this is the same. My x into y is again greater than 1. Okay, is it fine? So we have three different formulas for tan inverse of x plus minus tan inverse of y. Next property. So we similarly we will have for sin inverse of x and sin inverse of y. You can see there also we have again two formulas. One is when my x is greater than or equals to 0, y is greater than or equals to 0, and my x square plus y square is less than 1. In that case, you have one formula. The next formula it is exactly same, but you are subtracting that term from pi. When your x square plus y square is greater than 1. And for minus, okay, it is the same formula, be it x square plus y square greater than 1 or less than 1, the formula is same, pi minus sin inverse of x into under root of 1 minus y square minus y into under root of 1 minus x square. Similarly, we have for cos also, okay. Similarly, we have for cos also, cos inverse of x plus minus cos inverse of y is nothing but cos inverse of xy. Here if it is plus, then it will be minus over here, and here if it is minus, then it will be plus over here. Okay, into under root of 1 minus x square into under root of 1 minus y square. Again, this is for when our x square plus y square is less than 1. Again, if my x square plus y square is greater than 1, then you just have to subtract this term for pi. Similar thing we have done in sine also. So you have to be very careful when we are applying inverse trigonometry formula. Okay, in trigonometry we had only single formulas, but here we have different formulas. So you have to remember these values. You have to, okay, be very careful in seeing this. Is our value less than or equals to 1 or if it is greater than 1. So this is our property number 6. Okay, similar to the compound angles formula we had in trigonometry. Then next, property number 7. This is very, very important. If you see this, okay, we have written sine in terms of. So what we have written in this property number 7 is, we have written sine in terms of all the trigonometric ratios, then cos inverse in terms of all the trigonometric ratios, then tan in terms of all the trigonometric ratios, and cot in terms of all the trigonometric ratios. Students, please use your school email ID. It's because I'm explaining, I'm able to admit you. If I'm writing on the board, I will not be allowed to admit you. Okay, it will be difficult for me to admit you. Please use your school email ID. So now if you see the next property which is on your screen, okay, it is you are writing everything in terms of all the, okay, trigonometric ratios. So if you can see over there, sine inverse of x. Okay, so it can be written in terms of cos inverse, tan inverse, sec inverse, cosec inverse, and cot inverse. So that is what we have written. It can be written as cos inverse of under root of 1 minus x square. Again, it has come from, we know that 1 minus sine square be written as cos square. And 1 minus cos square can be written as sine square. And therefore, you have this term like 1 minus x square. This sine inverse of x can be written as tan inverse of x upon, okay, under root of 1 plus 1 minus x square. Sorry. Similarly, it can be written as cos inverse of, you just have to write reciprocal of this, so that will be 1 minus x square upon x. Okay, so we have written reciprocal because cos, we know it is reciprocal of tan. Similarly, for sec inverse, okay, sec inverse you will write reciprocal of cos. So cos you already know, so it will become under root of 1 minus x square over here. And similarly, it will be cosec inverse of 1 upon x. Why? Because if we just remember trigonometry, cosec is 1 upon sine. Sine is 1 upon cosec. So that relation becomes something like this over here. Okay, similarly, sec is 1 upon cos and cos is 1 upon sec. Similarly, when we write for cos, okay, here I will have sec 1 upon x. We will not write 1 upon sec inverse of it. Instead, here in inside we will write. Okay, so this is sine inverse in terms of all the trigonometric ratios. Again on your screen it is there, cos inverse of x. So now this value will be assigned to sine. So this value will become tan and this value will become cos. This value will become for, okay, cosec, and this value will become for sec. So if you remember one, the other values we just have to swap. So the value of cot will be swapped with tan, whereas the value of cosec will be swapped with sec, and the value of cos will be swapped with sine. So you just remember only one formula, that is for sine inverse of x. The cos inverse of x can be remembered by just swapping the values. Okay. Next on your screen is the values of tan inverse of x and cot inverse of x in all the trigonometric ratios. So again, to remember the formulas, if you see, when you are writing tan inverse of x, it is sin inverse of x upon under root of 1 plus x square. The only change is in the sign. Otherwise, the term is exactly same. Okay. So when you write for cos inverse, so it is from here only. You will just write 1 upon, and here you have to change the sign. For cot, we know tan is 1 upon cot, cot is 1 upon tan. So it will be cot inverse of 1 upon it. Similarly, for sec inverse. Okay. For sec inverse, it will be x upon under root of 1 plus x. So this will be for cosec. So your cosec inverse, so tan inverse in terms of cosec will be under root of 1 upon x square upon x. This is inverse of this, you just have to write. Inverse of sine. Similarly, sec inverse, just write, reciprocal of this, it will be 1 upon x square. So I hope you will be able to remember the formula. Now when you have to write for the cosec, you will just swap the values. Swap the values of cosec with sec and swap the values of sine with cos when you write it for cot inverse of it. So when you swap the values, so this will become sine inverse of 1 upon under root of 1 plus x square and this will become cos inverse of x upon under root of 1 plus x square. So when we wrote the formula for cos, the values we have just worked. Okay, so this will become tan inverse of 1 by x. Okay, ratios with co-ratios, you have to swap the values. So this values will get swapped. Okay, so now my sec inverse of x will become under root of 1 plus x square upon x, and my cosec inverse will become under root of 1 plus x square. Okay, so I hope you are understanding how to remember the formulas. Okay, next, the next thing which you can see on your screen is I have written something fundamental period. So what is a fundamental period? So if you just remember, we had written range, and I told you have to by heart the range and the domain of the function. Okay, so that is what we call it as fundamental period. Okay, so because if you remember, for sine I could have taken this much part, or I could have taken this part, or I could have taken this part. So I had many choices when we made inverse, okay, of a function. We had a lot of choices. We could have taken any part of the graph, but we had written some convention, and basis of that only we had taken only that particular part of the graph. So if it is line in the fundamental period, so which we had called it a fundamental period, or whatever ranges we had written, or the domains we had written for all the inverse trigonometric functions, those will be called as fundamental period. And the values which are lying in the fundamental period will be called as principal values. Okay, very important. What is principal values? The values which are lying in the fundamental period. Say for example, if I write sine inverse of x, then what will be the domain of this? What will be the range of this? Minus pi by 2 to plus pi by 2. So the values which are lying in between this only will be called as the principal value. All other values will be called as general values. And the values which are lying for sine over here will be called as principal values. Similarly, for the cos inverse of x, it will be 0 to pi. The range for cos inverse of x will be 0 to pi. So this is called as the fundamental period between 0 to pi. So the values which are going to lie between 0 to pi, those values will be called as principal values. All other values will be called as general values. Next, last property, property number 8 and property number 9. These are the properties used for the numericals. So we had seen one property, it was only related to tan inverse of x plus tan inverse of y. But suppose if I have to add 3 terms, in simple numericals it's easy. First we can add, suppose we have a numerical something like this, tan inverse of 1 plus tan inverse of 2 plus tan inverse of 3. So in such cases it is easy. You can select group of 2 and then whatever answer is there you can add with this. Okay, but I have some big here in the argument portion. If I'm having some big values, at that time it may become difficult, and that is why I've written the property number 8 over there, which you can see on the screen. It is for tan inverse of x, y and z. 3 terms if I have to add together. Then if I have tan inverse of x plus tan inverse of y plus tan inverse of z, then it can be written as tan inverse of x plus y plus z minus xyz upon 1 minus xy minus yz minus zx. Okay, easy to remember. 3 angles were added, so I have added 3 angles. Then I have subtracted the product, and then If you just remember the formula here, if you have positive, then here you have negative. Therefore, this is all a negative. So first you are multiplying 2, then the next, and then first and the third. So multiplying first and second, second and third, and then first and third. Okay, then the property number 9. The property number 9 is like, okay, in trigonometry we had sine to theta, cos to theta, tan to theta. Then we had formula for sine 3 theta, and we had formula for cos 3 theta. So the property number 9 is similar to that. Okay, the property number 9 is similar to that. So this 2 tan inverse of x can be written as tan inverse of 2x upon 1 minus x square. So it is similar if you just remember the formula. Tan 2x could be written as 2 tan x upon 1 minus tan square x. So we had this formula in the trigonometry. So instead of tan x, we just have to write x. That's it. Okay, the formula is similar. So here you had 2x, then it used to become x. Half angle it used to become. Now, here it is just opposite. If this is x, okay, here we are writing 2x. Okay, that is the only change when I am writing over here. So when I am writing over here, I have tan inverse of x, and when I am writing over here, I have the in totality, I have tan inverse of 2x. It's similar to kind of an half angle formula. If you remember, in terms of sine, the formula was sine to x in terms of tan could be written as 2 tan of x upon 1 plus tan square x. Similarly, if you remember, cos to x could be written as 1 minus tan square x upon 1 plus tan square x. This formula are from trigonometry only. You just have to write it as. Here I can write it as, okay, sine inverse of, and wherever there is tan x, you just put x. So this will become 2x upon 1 plus x square. Similarly, here I can write it as cos inverse of. So wherever there is tan, just put x over there. So this will become 1 minus x square upon 1 plus x square. So I hope you'll be able to remember by comparing it with your already known trigonometric formula. You already know the trigonometric formula, so I have just made you write this formulas on the basis of what you already know. Okay, so now we are done with the properties. Let us start with the numericals. Let us learn to apply all these properties. At any point of time, you are not able to understand anything, okay, you can unmute yourself and ask me the question. So let's start with the numerical. So let's learn to apply. Let us take as first numerical tan inverse of 1 plus tan inverse of 2 plus tan inverse of 3. I want to evaluate. Okay, I want to evaluate the value of this. Okay, I want to evaluate what will be the answer of this. So we know tan inverse of 1 is nothing but pi by 4. But we don't know what is the value of tan inverse of 2. We don't know what is the value of tan inverse of 3. So what we are going to do, we are going to add this. But before adding, we have to see what is the product. So here I have 2 and here I have 3. So 2 into 3 is nothing but 6. Therefore, your xy is greater than 1. So if you just remember, there were 3 formulae over there. Right? There were 3 formulae which were written. So we had, when xy is greater than 1, we had 2 formulas. And there again we have to see if x is greater than 0 and y is greater than 0. In this case, both are greater than 0. If you remember, the formula is tan inverse of x plus tan inverse of y can be written as, in this case, when your xy is greater than 1, x is greater than 0 and y is greater than 0, that is positive. In that case, it is pi plus tan inverse of, here if it is there is addition, so you will add over here and here you are going to subtract. If I apply this formula, I get over here pi plus tan inverse of x plus y, so that will be 2 plus 3 upon 1 minus x into y, that is 2 into 3. So I will get pi by 4 plus pi plus tan inverse of 5, 1 minus 6. So that will be pi by 4 plus pi plus tan inverse of 5 upon minus 5, that will be minus 1. Right? So I'll get pi by 4 plus pi, okay, minus, I can write it as, if you have doubts, you can write it as tan inverse of minus tan inverse of 1. We have written this property also for sine inverse, cosec inverse and tan inverse. These are odd functions. Therefore, I can write, okay, sine inverse of minus x is minus sine inverse of x, tan inverse of x minus x is minus tan inverse of x. So tan inverse of minus x is minus tan inverse of x. So I will get pi by 4 plus pi. Tan inverse of 1 is pi by 4. So plus pi by 4 minus pi by 4 gets cancelled and we get the answer is pi. Okay. So tan inverse of 1 plus tan inverse of 2 plus tan inverse of 3 is nothing but how much? 5. Okay. Let's do one more. Let's do one more. Tan inverse of 1 on tan inverse of 1 by 2 plus tan inverse of 1 by 3. Okay, last case I had written 2 and I had written 3. So this time I have, I think, 1 by 2 and 1 by 3. So when I do 1 by 2 into 1 by 3, I am going to get 1 by 6, which implies that my x into y is less than 1. Right? 1 divided by 6 is, but obviously less than 1. So I'll get x, y is less than 1. In that case, this formula can be directly written as tan inverse of x plus y upon 1 minus x. There will be no pi term over there when my xy is less than 1. So this we know it is nothing but pi by 4. So here it will become directly, there will be no pi term, it will be tan inverse of x plus y. That will be 1 by 2 plus 1 by 3 upon 1 minus 1 by 2 into 1 by 3. So I get pi by 4 plus tan inverse of 3 plus 2. So that will be pi by 6 upon here also 3 into the 6 minus 1. So this will also be 5 by 6. Okay, so 6 will get cancelled over here. So 5 by 5, that is 1. So I get 5 by 4 plus 5 by 4, that is 5 by 2. In last case, I got the answer as 5. In this case, I got the answer as 5 by 2. Now, if you would have made mistake of putting this pi over here, then you would have ended with the wrong answer. That is why, okay, these formulas are very important. You have to see this condition, it's very important. Okay, we have to see this condition, it's very important. If xy is greater than 1 or if xy is less than 1, okay, seeing this is very important. Let's see next question. Next question. If cos inverse of x plus cos inverse of y plus cos inverse of z is equals to pi, then the value of x square plus y square plus z square plus 2xyz is equal to option A 1, option B -1, option C 0, option D 2. This has come in your IIT 2007. Similar sum we had solved in last class also, but at that time you had something a different value. This time you have some different value. Okay, and then you have to concentrate on this given equation also. Last time we had something x raised to 100 plus y raised to 100 plus z raised to 100. And if you remember, we had directly, the numerator was easy. Directly we had got the value of, okay, x, y and z as 1, 1, 1. Because the condition was like that. But this time it is not, the case. So let's see. So let me take this over there. So I'll get cos inverse of x plus cos inverse of y is equal to pi minus cos inverse of z. It's not that you should take only cos z over there. You can take anything, any one over there. It's okay. We are going to read the answer. There's only. So now if you remember, my cos inverse of minus x is not cos inverse of x. It's even not minus cos inverse of x, because if you just remember the graph, it is neither odd neither even. So this formula could not be applied. But if you remember, we had written as one of the property where we had written my cos inverse of x can be written as pi minus cos inverse of x. This was one of the property. If you see, similar term is over there. Pi minus cos inverse of z. Second I written cos inverse of minus z. Okay. And here I can apply the formula of cos inverse of x plus cos inverse of y. What is that? Okay, what is the formula of cos inverse of x plus cos inverse of y? The formula for this is cos inverse of xy minus, when it is plus it will be minus, into under root of 1 minus x square into under root of 1 minus y square. Then equal to sign, and instead of this I can write cos inverse of minus y. Now you have cos inverse term on both the sides. Okay, therefore you can do one thing is mentally you can just cancel it cos inverse, or technically if you are not understanding how we are cancelling, then you can take cos on both the sides. So cos and cos inverse will get cancelled here, so cos and cos inverse will get cancelled. Whichever way you are comfortable. So I can directly cancel out cos inverse over here and cos inverse over here. So I'll get over here as xy minus under root of 1 minus x square into under root of 1 minus y square is equals to minus z. Okay. So this term I'll take over there and let me bring this term over here. So I'll get xy plus z. It was minus z here, it will come, it will become plus. Similarly, here it is minus, z will go, it will become positive. So under root of 1 minus x square into under root of 1 minus y square. Almost we are on the verge of getting this what they have asked. Okay, but if you see, I don't want here square root, I want this x square y square term. So I'll square on both the sides, so my square root will get cancelled, so I'll get xy plus z the whole square is equal to, here the square root will get cancelled, so I'll get 1 minus x square into 1 minus y square. So let us expand this. So I'll get x square y square plus 2 xyz plus z square. As equal to, here let us expand 1 into 1, that is 1 into minus square, so that will be minus x square into 1, so that will be minus x square into, so this will be x square minus will become plus. So x square y square and x square y square gets cancelled. So I get over here 2xyz plus z square is equal to 1 minus y square minus x square. So let us see the given. So this 2xyz term is also there, z square term is also there, and x square plus y square should be positive. So this term I'll take over here. So I get x square plus y square plus this z square plus 2xyz is equal to, and what remains on RHS side is only 1. So we get the answer. The value of this equation is nothing but 1. So here we have this option number A. Okay, so yes, we have option number A. Clear? Okay, let's do next numerical. So similar kind of numerical. Next, this inverse trigonometry is completely on formula. Next numerical, it has come in 2005. IIT in the year 2005. If cos inverse of x minus cos inverse of y by 2 is equal to alpha, then 4x square minus 4xy minus 4xy into cos alpha plus y square is. So we have to find out the value of this given equation, and the options are option number A 2 sin square alpha, option number B 4, option number C 4 sin square alpha, and option number D minus 4 sin square alpha. So let's solve this. You have to solve this in the similar manner. In similar fashion, we had done last numerical, but there he had given us the value as pi. Here he is giving some distance, some arbitrary constant as alpha. So let's solve it. So we have to apply the formula of cos inverse of x minus cos inverse of y. So that is cos inverse of x minus cos inverse of y. So this formula is nothing but cos inverse of xy. If it is minus, then here it is going to be plus into under root of 1 minus x square into under root of 1 minus y square. So this is the formula. So let's apply this. Here we'll get cos inverse of x into y. Instead of y, we have y by 2 plus under root of 1 minus x square into under root of 1 minus. Instead of y, we have y by 2. So this will become y square by 4 is equals to alpha. So I'm writing is equals to alpha. Okay, hope it's clear. Now, if this is cos inverse, if this goes on this side of the is equal to, then cos inverse will become cos, and here I'll have xy by 2 plus under root of 1 minus x square into under root of 1 minus y square by 4 is equal to cos alpha. Okay, so slowly and steadily we are trying to reach on this equation what is asking us. So I am not going to take LCM over here. I could have taken LCM 4, LCM over here, and then I would have taken 2, okay, outside, and this 2, then I could have multiplied over here directly. But then I'll get here term 4 minus y square, and here I have a little bit different term. So I'm not doing that directly. Next, I want square over here, so which means I have to remove the square root from here. So let me take this term over there. So I'll get under root of 1 minus x square into under root of 1 minus y square by 4 is equals to cos alpha. This is plus, there it will go, so it will become minus xy by 2. Okay, now let's square on both the sides so that this, okay, root gets cancelled. So on squaring, I'll get 1 minus x square into 1 minus y square by 4 is equals to, here when I square, so a minus b the whole square, so this will become cos square alpha minus 2 into cos alpha into xy by 2 plus x square y square by 2 square, that is 4. So here when I multiply, so I get 1 minus y square by 4 minus x square minus minus will become plus x square y square by 4 is equal to this 2, and this 2 will get cancelled. So I'll get cos square alpha minus cos alpha into xy plus x square y square by 4. So same term is there on both the sides. So this x square y square by 4, x square y square by 4 will get cancelled out. And now I require something like this 4x square term. So I'm going to take LCM over here. So I'll get 4 minus y square minus 4x square upon 4 is equals to, when here, okay, I can, here it will become cos square alpha minus xy cos alpha. So this 4 goes over here, so I get 4 minus y square minus 4x square is equals to 4 into cos square alpha minus 4xy cos of alpha. So now I have this term over here minus 4xy cos of alpha. So I'm having this term over here also minus 4xy cos alpha. Now next what I need is plus 4x square and plus y square. So I'll take this over there and I'll take this over there. Okay. So those both plus plus will go over there. I don't require this term because it is not there over here. So this term I'll take it over here. Let's see what happens. So I'll get 4 minus 4 cos square alpha is equal to, this is minus, that will go, so it will become plus, it will become 4x square plus y square minus 4xy cos of alpha. So this entire term we have got over here. This is what is asking us to find out the value of 4x square minus 4xy cos alpha plus y square. So we have this term over here. We just need to simplify this. Okay, because the options are not in that form. The entire options are in terms of sine square. So we have to convert this. So I'll just take 4 common. So inside it will become 1 minus cos square alpha. So here I have 4x square minus 4xy cos alpha plus y square. So what will be the option? So 1 minus cos square is sine square. So I'll get 4 sine square alpha is equal to this. So my answer is 4 sine square alpha. So which is nothing but my option number 3. Okay. This has come in the year 2005. So whatever numericals we are doing, all are exam numericals only. Okay. And this has come in the year 2005. Either it is asked in your IGSC, CBSC, or either it is asked in GW. I hope you have understood this numerical also. Okay, let's do next numerical. Find the value of cot inverse of 21, cot inverse of 21 plus cot inverse of 13 plus cot inverse of minus 8. So I have to find out value of this. What will be value of this given question? So we have not written any formula for cot inverse of x plus y plus z. And when we have small numbers, it is not required also. We can take it into the groups and we can do it. So let me apply the formula for this two first and then we'll apply over there. So cot can be written as 1 by tan. Tan of into 1 by. So this cot inverse of 21 can be written as tan inverse of 1 by 21. Why? Because cot inverse of x is tan inverse of 1 by x. Therefore, I'll get tan inverse of 1 by 21. Similarly, cot inverse of 13 can be written as tan inverse of 1 by 13. Okay, and cot inverse of minus 8 can be written as tan inverse of 1 by minus 8. Okay, so first I have applied the property. Next, we'll apply the formula over here. So if you see 1 by 21, 1 by 13. So x into y is going to be less than 1. So if x into y is less than 1, then we don't have to write pi plus minus something. Okay, we don't have to write pi plus minus something. We can directly write it as tan inverse of, here it is plus. So tan inverse of x plus y upon 1 minus x into 1. And here tan inverse of minus x is minus tan inverse of x, because tan inverse and cosec inverse, okay, these are odd functions, and therefore I can write it as minus tan inverse of 1 by 8. So this minus sign, okay, has come over here. So let's solve this. So we'll get tan inverse of 13 plus 21 upon 21 into 13. The whole divided by 21 into 13 minus 1 upon 21 into 13 minus tan inverse of 1 by 8. So this 21 into 13, 21 into 13 will get cancelled. So I'll get tan inverse of 13 plus 21, so that will be 34. 21 into 13, that will be how much? 21 into 13, 3, 1, 3, this is 21. That will be 273 minus 1, so that will be 272 minus tan inverse of 1 by 8. Now 34 upon 272. That is nothing but 34 ones are 34 eights are 34 ones are 34 eights are. So I will get tan inverse of 1 by 8 minus tan inverse of 1 by 8. So we get answer as 0. So the answer for the given question, cot inverse of 21 plus cot inverse of 13 plus cot inverse of minus 8 is nothing but 0. Okay, I hope it's clear. Let's write the next numerical. Next question has come in CBSE exam. Find the value of x if for sin inverse of x plus cos inverse of x is equal to 3 pi by 4. So this time we need to find out the value of x. We don't need to evaluate an equation this time. This time he's telling us to find out the value of x. Okay, so let's do it. So it's given us 4 sin inverse of x plus cos inverse of x is equal to 3 pi by 4. Now, do we have any formula for sin inverse of x plus cos inverse of x? Do we have any formula? We don't have. We have formula for sin inverse of x plus sin inverse of y. We have formula for sin inverse of x minus sin inverse of y. Similarly, we have formula for cos inverse of x plus minus cos inverse of y. We don't have formula for this mixed one. So how should we do this? Then we have to remember the property, one property we had written, which was like an identity, that sin inverse of x plus cos inverse of x is equal to pi by 2. So either convert everything in terms of sin or convert everything in terms of cos. Okay, then only you can apply the formula or you can add or subtract. So from here I can get cos inverse of x can be written as pi by 2 minus sin inverse of x. So I'll put this value over here, so I'll get 4 sin inverse of x plus, now instead of cos inverse of x, I can write pi by 2 minus sin inverse of x is equal to 3 pi by 4. So now we have over here 4 sin inverse of x minus sin inverse of x, which will be 3 sin inverse of x. This will go over there. So 3 pi by 4 minus pi by 2. So that will become 3 pi minus 2 pi upon 4 So I'll get 3 sine inverse of x is equal to 5 by 4. So this will go over there. So I'll get sine inverse of x is equal to 5 by 2. Therefore, x is equal to, if this goes over there, it will become sine of 5 by 2. So the value of x is sine of 5 by 12. We wanted us to find out the value of x, and we have got the value of x, okay, as sine of 5 by 12. Hope you have understood. If you have any doubt, then please unmute your mic and ask me, or you can reply it into the chat box. If you're not understanding anything, clear? Okay. Let's move ahead. One more numerical of this pregnancy. Okay, find out the value of x if tan inverse of 4 plus cot inverse of x is equals to 5 by 2. Okay, see the way he is asked. This time he is not given x like the last, but this time he is given tan inverse of 4. So can I write cot inverse in terms of tan? Yes, we have this property. Tan inverse of x plus cot inverse of x is equal to 5 by 2. Therefore, cot inverse of x can be written as 5 by 2 minus tan inverse of x. So let's put over there. So I'll get tan inverse of 4 plus 5 by 2 minus, instead of cot x, I can put 5 by 2 minus tan inverse of x is equal to 5 by 2. So now this 5 by 2 and this 5 by 2 gets cancelled. So I'll get tan inverse of 4 minus tan inverse of x is equal to 0. This goes over there. So I'll get tan inverse of 4 is equals to tan inverse of x. So now tan inverse will get cancelled, and I'll get x is equal to 4. Just a minute. I'm just signing out from the laptop. Just a minute. Okay, so we got the value of x is equals to 4. Is it clear to everyone? Let's do next numerical. So this is both the numericals which we did now. This was of your board level. These were board exam numericals. Now again we'll go to IIT numericals, GEE1. So next is tan of cos inverse of 4 by 5 plus tan inverse of 2 by 3 is option number A 6 by 17, option number B 7 by 16, option number C 16 by 7, option number D none. None of this. Okay, so let's solve this. Now inside a tan it is not given tan x. So instead of x, there is this cos inverse of x plus tan inverse of something. So now let me assume this as let cos inverse of 4 by 5 be A and let tan inverse of 2 by 3 be B. So now the advantage of this is my question will get reduced to tan of A plus B. Now the advantage of assuming this is my question reduces and now I know the formula for this. Tan of A plus B is nothing but tan A plus tan B upon 1 minus tan A into tan of B. So now if I get the value of tan value of tan B and if I substitute in this equation number 1, then I'll get the answer for the given question. Okay, so let's find out tan A. So how do you find out tan A and tan B? It's simple. So here we have cos inverse of 4 by 5 is equal to A. So if this goes over there, so this cos inverse will become cos, so I'll get 4 by 5 is equals to cos of A. So this is my angle A, and if my cos of A is 4 by 5 means my adjacent is 4 and my hypotenuse is 5. So but obviously this side will be nothing but by Pythagoras it will be nothing but 5 square minus 4 square. So that will be nothing but 25 minus 16. So that is 9. So my x will be plus minus 3. Okay. So it is positive over there. So I take positive value is not, he has not given us quadrant. He has not said, again you have to, okay, be careful and see the question if he is talking about second quadrant, third quadrant or anything. Here if he has not said about any quadrant, okay, and here if there are no negative values, I can consider it as first quadrant. Okay. So here I am taking the value as 3. So from here I can get the value of tan A. So tan will be opposite upon adjacent. So here my opposite is 3 and my adjacent is 4. So I get the value of tan A as 3 by 4. Similarly, I can find out the value of tan B. So from here I have tan inverse of 2 by 3 is equal to B. If this tan inverse goes over there, so it will become tan. So I'll get 2 by 3 is equal to tan of B. So now I have the value of tan B also. I have the value of tan A also. I can substitute over there. So I'll get tan A is nothing but 3 by 4. So 3 by 4 plus tan B, that is 2 by 3 divided by 1 minus tan A into tan B. So 1 minus 3 by 4 into 2 by 3. So that is I will get 9 plus 4 upon 12. The whole upon 12 minus 6 upon 12. So this 12 and this 12 gets cancelled. So 9 plus 4 is going to give me 13. 12 minus 6 is going to give me 6. So no, sorry, mistake. So 3 into 3 is 9. 9, 4 into 2, that is 8. So it will become 9 plus 8, so that will become 17 by 6. So the answer for the given question is 17 by 6. So do we have this option 17 by 6? No. We have a reciprocal option over there, which is 6 by 17. What we have got is 17 by 6. So our answer is going to be option number D, that is 9. The value of the given question is 17 by 6. Okay, which is not there in the option. This is the reciprocal, 6 by 17. Is it fine? Everyone has understood?
Yes, sir.
Everyone has understood? Okay. So let's do next numerical. Next numerical has come in the year 2003. Okay. Tan inverse of y is equals to tan inverse of x plus tan inverse of 2x upon 1 minus x square. Then value of y is then value of y is option number A, 3x minus x cube, 3x minus x cube upon 1 minus 3x square. Option number B, 3x plus x square upon 1 minus 3x square. Option number C, 3x minus x cube upon 1 plus 3x square. Option number D, 3x plus x square upon 1 plus 2x square. Let's see this. This has come in the year 2003. Let's solve this numerical. If you guys are not understanding at any point, please unmute yourself and ask me what step you have not understood or what concept you have not understood. So we need to find out the value of y. And in the question, y is already on one side. So we are not going to touch to LHS. We'll only touch to RHS. We'll try to simplify the RHS and let us see what answer do we get. So here there are no numbers are there. So if no numbers are there, by default, you should consider your xy is less than 1. So by default, when you consider your xy is less than 1, then you get tan inverse of x plus tan inverse of y as nothing but tan inverse of x plus y upon 1 minus x into y. So here I can write it as tan inverse of y is equal to tan inverse of x plus 2x upon 1 minus x square upon 1 minus x into y. 1 minus x into 2x upon 1 minus x square. So let us simplify this. We will get the answer. So now here I have this tan inverse and here also tan inverse. So tan inverse will get cancelled and I get y is equal to, and let's simplify this, x into 1 minus x square plus 2x The whole upon the denominator is same, it will get cancelled out. Here also 1 minus x square minus x into 2x, that will become 2x square. So let's simplify this. So then x gets multiplied inside, so I get x minus x square plus 2x upon here I have 1 minus x square minus 2x square. So here I'll have minus 3x square. Oh, sorry, x into x square will become my x cube. So having this, and x plus x will become my 3x. So this will become 3x minus x cube upon 1 minus 3x square. Yes, it was simple numerical. So the answer is nothing but option number A. The value of y is 3x minus x cube upon 1 minus 3x square. Okay. Let's do next numerical. This is coming 2008. The next numerical has come in 2008. If x is greater than 0 and less than 1, then under root of 1 plus x square into x cos of cot inverse of x plus sine cot inverse of x the whole square minus 1 the whole raised to 1 by 2 is equal to or is option number A, x upon under root of 1 plus x square. Option B, x. Option C, x into under root of 1 plus x square. And option D, under root of 1 plus x square. So let's solve this. This is come in the year 2008. At that time it was only JEE exams, it was no mean or advanced. That time it was asked. If you see, the question is in terms of x and you have sine inverse, cot inverse, cos inverse, and the option is only in terms of x. So somehow it should strike in our mind that we have to cancel all this cot inverse of x or sine cot inverse of x, whatever we have, it should get cancelled out. Only if we are successfully able to cancel out, we'll be able to get the answer which is in the terms of x. Okay? And now we have cot in terms of cos also, and we have cot in terms of sine also. But the term over there is 1 upon under root of 1 plus x square and x upon under root of 1 plus x square. And then you have this whole square over here. Then you have this minus 1. Then you have the whole raised to 1 by 2. So if I go by that technique, I'll get the answer. But my simplification will become very difficult. If I'm using the formula of converting cot inverse into cos inverse, and converting cos inverse into sine inverse. If I'm using that formula, my simplification will become very complex, and we know in the exam we have maximum 2 to 3 minutes only for one numerical we can get. So we always have to choose the technique which is going to give us the answer in minimum time. So here if I see, here also I have cot and here also I have cot. So let me assume, like we have done in previous numericals also, let cos inverse of x is equal to say theta. You can take anything. So from here I'll get, if this cot goes over here, so I'll get x is equal to cot of theta. So let's solve it. So let's substitute the values over here. So I get 1 plus cot square theta into x. So instead of x, I can write cot theta. So cot theta into cos of. Instead of cot inverse of x, I have assumed cot inverse of x is equal to theta. So instead of cot inverse of x, I just write theta, so I get cot theta into cos theta plus sine of cot inverse of x. Cot inverse of x is nothing but theta. So here I will substitute theta, the whole square. So now it got reduced as cot theta into cos theta plus sine theta the whole square minus 1 the whole raised to 1 by 2. So this will become 1 plus cot square theta. So cot theta can be written as cos by sine. So this will become cos square theta upon sine theta plus sine theta the whole square minus 1 raised to 1 by 2. So this will become 1 plus cot square theta. So here I'll take LCM. So this will become cos square theta plus sine square theta the whole upon sine theta the whole square minus 1 the whole raised to 1 by 2. So now cos square theta plus sine square theta is 1. So 1 square it will be 1 and 1 upon sine square theta. So I will get 1 plus cot square theta into, so here I am going to get 1 upon sine square theta minus 1, so just the whole raised to 1 by 2. So I'll get, let me put it as, I want the final answer in terms of x. So let me not, let me keep it as x only. Here I'll get 1 minus sine square theta when I take LCM, 1 minus sine square theta upon sine square theta the whole raised to 1 by 2. Raised to 1 by 2 means square root. So I'll get under root of 1 plus x square into, this raised to 1 by 2 can be written as square root 1 minus sine square theta is cos square theta. So this will become cos square theta by sine square theta. So this will become under root of 1 plus x square into under root of cos square by sine square. So cos by sine is cos. So this will become cot square theta. So square and square root will get cancelled. So I'll get 1 plus x square theta into cot of theta. And cot theta is nothing but x. So I get over here under root of 1 plus x square into x. So yes, option number C. So we get the answer as option number C. Okay, this technique will help us in Okay, making our calculation simple and getting the answer quickly. Okay, I hope you have understood. Let's see next numerical. Let's find out the value of x. This is coming 2004. Find the value of x for which sine cot inverse of 1 plus x is equals to cos tan inverse of it. You see this numerical carefully. It has come in your exams in 2004. We have to find out the value of x for which this given situation satisfies. Now it's not like the last case where he has given us the options. So we have to think how we have to simplify. Here he has not given us any options. So we can simplify the way we want. And the most important thing over here is I have to find out the value of x. So if I have to find out the value of x, I have to remove this sine also should not be there, cot inverse should not be there, cos should not be there, tan inverse should not be there. So how can we cancel? So we have one property only. Sine inverse of sine x, both are going to get cancelled, or sine inverse of x, both are going to get cancelled. Similarly here, if you have cos and cos inverse of x over there, we will be able to cancel it. So we just have to write the formula of tan inverse of x, we have to write in terms of cos. Similarly, cot inverse of x, we have to write in terms of sine inverse. Then we'll be able to cancel that. So what is the formula of cot inverse of x in terms of sine inverse of x? Do you guys remember? What is cot inverse of x? Today when we started the lecture, we started with this formulas only. Cot inverse of x in terms of sine inverse of x can be written as sine inverse of 1 upon under root of 1 plus x square. Similarly, I have to write tan inverse of x in terms of cos. So tan inverse in terms of cos. We have written everything in terms of sine and cos. So what is the formula? Do you remember? Tan inverse in terms of cos inverse. It will be cos inverse of 1 upon 1 plus x square. If you just remember, we just have to swap the values. If cot inverse is having this, so answer here also here is going to be the same. So now if I see over here, now here instead of x, I have 1 plus x. So that is the only thing which you have to remember. So when I write over there, so this will become sine of, here cot inverse can be written as sine inverse of 1 upon under root of 1 plus x square. So now instead of x I have here I have 1 plus x. So I will have to write over here 1 plus x the whole square is equals to cos of tan inverse of x can be written as cos inverse of 1 upon under root of 1 plus x square. So sine and sine inverse will get cancelled, cos and cos inverse will get cancelled. So here I get 1 upon under root of 1 plus I'll expand this. So 1 square is 1 plus 2x plus x square is equal to here cos and cos inverse gets cancelled. So I get 1 upon under root of 1 plus x square. So this 1 gets cancelled. So I get over here under root of 1 plus 1 is 2. So 2 plus 2x plus x square is equal to here I'm going to get under root of 1 plus x square. So now if I want to remove the square root, I have to take square. So on squaring both sides, I'll get 2 plus 2x plus x square is equal to 1 plus x square. So x square gets cancelled. This 2 I'll take over there. So I'll get 2x is equal to 1 minus 2. That is nothing but minus 1. So I get x is equal to minus 1 by 2. So he wanted us to find out the value of x, which is minus 1 by 2. But this formula is important. Without knowing this formula, you will not be able to solve. Property where we had written or any trigonometric ratios in all the trigonometric ratios. Okay? So here we wrote cos inverse in terms of sine inverse, and here we wrote tan inverse in terms of cos inverse. I hope you have understood. Now let's do next numerical. This is an important one. Okay, at first look it may look very complex, but if you apply the formula properly, by understanding you will get the answer. Let's see the next numerical. To find the value of tan theta. Find value of tan theta if A, B and C belongs to real numbers. If A, B, C all belong to real numbers and theta is equal to, and the value of theta is tan inverse of under root of A into A plus B plus C upon BC plus tan inverse of under root of B into A plus B plus C upon AC plus tan inverse of root of C into A plus B plus C upon AB. So I have to find out the value of tan of theta. If the value of theta is this has come in the year 1981, and you should not consider that such old or the questions which are asked, the similar questions will not get repeated. But the similar questions, not the same, but the similar questions are getting repeated, and this numerical is important from the understanding point of view. Now you need the value of tan theta. If I take tan on both the sides, and if I can write this tan inverse as only simple one tan inverse, so I'll get some kind of a value on this side, and then I can say tan of theta is equal to say so and so. Okay, but how do I apply this? Now if you see here, this is tan inverse of x, tan inverse of y, tan inverse of z. If you remember, today we just saw one last property number 8. The tan inverse of x plus y plus z can be written as tan inverse of x plus y plus z minus xyz upon 1 minus xy into yz into, okay. So here the terms are very big. How to solve this? Here it may look very complex and it has come. You just see how much big question they have asked. It may look complex, okay, but if you simplify it, you will get that. So we know the formula for tan inverse of x plus tan inverse of y plus tan inverse of z can be written as tan inverse of x plus y plus z minus xyz upon 1 minus xy minus yz minus xz. So if I'm able to successfully write this in terms of something like this, and then when if I take tan on both the sides, so I'll finally get the value of tan, which is asking us in the question. So first, as the terms are very big, don't directly put into the formula. We'll find out the value of x plus y plus z. We'll find out the value of x, y, z. Then we'll find out the value of numerator. Let's see what we are getting of the numerator and then we'll worry about the denominator. Because you can see the terms are very big. See the x, see the y and see z. The terms are very big. So don't directly put into this formula. Okay. So let's find out the value of, as per this, x plus y plus z. So this is my entire x, this is my entire y, and this is my entire z. So let's find out x plus y plus z. It will be under root of a into a plus b plus c upon bc plus y is under root of b into a plus b plus c upon ac plus c into under root of a plus b plus c upon ab. So everywhere we have this common a plus b plus c, so that term can be taken as common. So under root of a plus b plus c, let us take this term as common. So what will remain inside over here is under root of a upon bc. Here I'll have under root of b upon ac, and here I'll have under root of c upon ab. If we see over here, everywhere only one term is missing. If I here multiply and divide by a, I'll get abc. Here if I multiply and divide by b, I'll get abc. Here if I multiply and divide by c, I'll get abc. So then the denominator will become same. So what I'm going to do, I'm going to multiply and divide here by a, multiply and divide here by b, multiply and divide here by c. So then I'll get this value of x plus y plus z. As per the formula, I'll get it as root of a plus b plus c into square root of a squared upon abc plus root of b squared upon abc, or you can separate it like this, plus root of c squared upon root of abc, so which can be written as square root of a plus b plus c into square and square root will get cancelled here, so square and square root will get cancelled here also, and here we have denominator same as under root of abc, so which can be written as a plus b plus c upon under root of abc. So we got the value of x plus y plus z as under root of a plus b plus c into a plus b plus c upon under root of abc. Okay, let's find out the value of this x into y into z. So x into y into z, so you have to multiply this entire term. Okay, so everywhere you have this ABC, ABC, ABC. So I can write the whole raised to cube because we are going to multiply this. So the same term is going to get multiplied again and again. And then over here I am going to get under root of A into B by C into. From here I will get B upon AC, and from there I will get C upon AB. Again last time, multiply and divide by A, multiply and divide by B, multiply and divide by C. And here, okay, root of x the whole cube can be written as x root x. Right. So similarly here, I can write this term as a plus b plus c into root of a plus b plus c. And here a square to square and square root will get cancelled. So here I am going to get a, here I am going to get b, here I am going to get c, and here I am going to get ABC into ABC into ABC. So I will get ABC the whole cube. From here I have multiplied and divided by, so here I am getting ABC, here I am getting ABC, here I am getting ABC. So I will get ABC, root of ABC the whole cube. So again which can be written as, so this will become A plus B plus C into root of A plus B plus C upon. This can also be written as x root x. So this can also be written as this can also be written as ABC into root of ABC. So this ABC gets cancelled. Now you observe these terms. So here after simplifying the value of x plus y plus z is root of a plus b plus c into a plus b plus c upon root of ABC. Here the value of x, y, z, the value of x, y, z is also the same. Okay, a plus b plus c into root of a plus b plus c divided by root of abc. And if you see in the over here in the formula, there is the minus sign over here, and the terms are same. So when there is minus sign and the terms are same, but obviously you are going to get 0 in the numerator. You are going to get tan inverse of 0 upon something, whatever is the denominator, 0 upon anything is 0. Right? So tan inverse of 0 you are going to get 0. Okay? So your tan inverse of 0 will be 0. You get the value of tan theta as 0. So this is your answer. I hope you have understood. Is it clear? Everyone has understood each and every step of this numerical. Okay, though it has come in 1981, I have purposely chosen this numerical because if you see, it really has a technique. If we don't use this technique and if we don't use this formula, we are not going to get anything because the terms are very big. The values of x, y, and z are very big, and upon that we have square root also. The simplification becomes very difficult. So we have applied some technique. If you have not understood, please tell me. If you have understood, then I'll go to the next numerical. Everyone has understood?
Yes, sir.
Okay. So let's do next type of numericals now. We'll do numericals on finding out the principal values. So today we saw this also. What is the principal value? Value lying in the fundamental period will be called as principal value. So this is nothing but values lying in the domain or range of the given function. So the values which are lying in the domain or the range of the given function, okay, those will be called as principal values. So we very well know for sine inverse it is minus pi by 2 to plus pi by 2. So any values which is lying between these two, only that value will be called as the principal value, not any other value. Okay. Similarly, for cos, if the value is lying only between 0 to pi, it will be called as the principal value. Otherwise, it will not be called as the principal value. So let's see some numericals. You will get an idea as to what is principal value and how to find out the principal value. So suppose I have something like this, cos inverse of cos of pi by 2. I am telling find principal values of the following. The very first question I am taking is cos inverse of cos of pi by 2. So now here this is not equal to pi by 2. Why? Because I am talking about principal values. Here you will not be able to cancel out cos and cos inverse and write it as pi by 3. Because how much will be pi by 3? So if you don't remember, it's okay. You just remember this. Pi is equal to 180 degrees. So 5 pi by 3 will be nothing but to multiply and divide by 5 pi by 3 here also. So here also I'm going to do multiply by 5 divided by 3. 3 ones are 360s are. So this is 300 degrees. And the domain for cos is zero to 5. That is nothing but 0 to 180 degrees. So the angles which are lying between 0 to 180 degree, only those values will be considered as the principal value. And here in the given question, okay, the angle which is said is nothing but 300 degree. So this doesn't lie in the fundamental period or the domain which is 0 to pi. Hence, I cannot say that cos inverse of cos of 5 pi by 3 is equal to 5 pi by 3. No. So you cannot write like this. This is wrong. So then we'll have to find out the value. So how can we do it? You can write it as cos inverse of okay, 5 pi by 3 we have to break, either we have to add in pi plus minus, or you have to do 2 pi plus minus, and we have to see where we'll get this value as 5 pi by 3. So if I do suppose if I do 2 pi minus pi by 3, so 3 into 2 that will be 6, 6 minus 1 that will be, so I'll get 5 pi by 3. So this 5 pi by 3 can be written as 2 pi minus pi by 3. So what I've done is I've written 5 pi by 3 as 2 pi minus pi by 3. Now we know that cos of 2 pi minus theta. So it will be in the fourth quadrant, and fourth quadrant cos is positive. So cos of 2 pi minus theta is cos theta. So I'll get cos inverse of cos of pi by 3. Okay, why? Because cos of 2 pi minus theta is nothing but cos theta. So therefore cos of 2 pi minus pi by 3 will be nothing but cos of pi by 3. So now cos and cos inverse will get cancelled and I'll get the value as pi by 3. Therefore the principal value of cos inverse of cos of 5 pi by 3. So the principal value of this is pi by 3. So principal value for cos inverse of cos of 5 pi by 3 is nothing but pi by 3. Everyone has understood this? Everyone has understood how I have found out this value of principal value? Now you take pi by 3, so but obviously pi by 3 lies between 0 to pi. Pi by 3 is how much? 180 by 3, so that is 60 degrees. So 60 degree lies in the domain, so my answer is right. So any value which is lying in the domain will be called as the principal value. Okay, hope it's clear. And let's see next one more. Cos inverse of 7 pi by 6. Cos inverse of cos of 7 pi by 6. Now again this will not be equal to 7 pi by 6. Because when we do 7 pi by 6, so the 7 pi by 6 is 7 pi by 6, so that will be 7 by 6 into 180. So 6 1s are 6 3s are, so that is 210 degrees. So 210 is not lying in this domain, so I cannot write cos inverse of cos. So here cos and cos inverse will not get cancelled. I will not write it as 7 pi by 6. And again what I will have to do, I will have to find out the principal value. So cos inverse of cos of 7 pi by 6 can be written as cos inverse of cos of. Again you have to do 2 pi plus minus something or pi plus minus something and try to get this value. So suppose if I write 2 pi minus pi by 6, then 6, 12. No, this will not work. If I write pi plus pi by 6, so 6 into pi, so 6 plus 1, that is going to give me 7. So this 7 pi by 6, okay, can be written as pi plus pi by 6. Okay, so now this cos can be written as cos inverse of, now cos of pi plus theta. Okay, so it can be written as pi plus pi by 6, or can I write pi plus pi by 6? No. So I get here cos of pi plus theta, it is going to go in third quadrant. In third quadrant cos is negative. So I'll get minus cos of pi by 6. So I'll get cos inverse of minus cos of pi by 6. Okay. Or if I write 2 pi plus pi by 6, I'm not going to get 2 pi minus pi by 6. Then also I'm not going to get. I have only this option. Now you directly cannot cancel out this. Now here you have minus sign over here. You cannot directly cancel out it. But cos inverse of minus can be written as cos inverse of minus x can be written as pi minus cos inverse of x. So now this you will have to write it as pi minus cos inverse of x. Here x is your pi by 6. You will get pi minus. This is the value of cos inverse of cos of 7 pi by 6. So pi minus cos inverse of, oh, sorry. So this will be pi minus cos inverse of x. So this will be pi minus cos inverse of pi by 6. So now cos inverse and cos will get cancelled. So I'll get pi by 6. Okay. So it will be 6 pi minus pi. So that will be 5 pi by 6. So therefore cos of 7 pi by 6, the value of this is nothing but 5 pi by 6. Is it clear to everyone? Any doubt in this? If you have not understood any step, then please ask me. I have applied this property. Okay, cos inverse of minus x can be written as pi minus cos inverse of x. So pi minus cos inverse of x is my this. Okay, so this is how I got it. Is it clear for everyone?
Yes, sir.
Okay, so our time is also done. So I hope everyone has understood about principal values. Two or three more problems we'll see of principal values, and then again we'll do some numericals which have come in JEE Advanced, and those are coming means in the next lecture. So we have one more lecture in this week, right? So please, I have given you the PDF also, and in the last lecture also I have given you PPT. Please buy out all the formulas. Okay, please buy out all the formulas without which we cannot do any numerical in this chapter. I'll send you the recordings like last time. Okay, have a nice day ahead.
Thank you, sir.